Okay, so this is assignment 5 for systems programming. I'm just going to go through my 3 programs. So the first question, we have a server.c and a client.c. And what will happen is the server will be waiting on the client to open, and then uh, the client will write inside the client, and that information will be transferred to the server um, using FIFOs, right? Which are just like named pipes, I guess. Um, yeah, so let me just show you that. Nano client, let's see. Okay, so in our client, oh wait, I guess I should have, let's show the server first. Nano server, let's see. So Um, just a little string saying we received your message. Some error checks. So we delete it if it already exists, and we create the FIFO. These are just the permissions. We're making the FIFO. Same thing with the client FIFO. Some error checks, and then it'll just be waiting for the client, right? So it just waits basically forever until the client will actually open and run. Um, so then we open it for reading only, and then it's just waiting. And then once the client opens, we got it for reading. We sleep, and then um, we're just waiting for both sides to be connected through the FIFOs. They get connected, and then um, this is optional. We didn't have to do this, but it'll just show. Actually, I'm just going to take that out because why not? Um, so then we're just going to be reading from the client side, right? And then printing to the server via the FIFOs. Um, this is just saying when there's a new line character, which is 10. Um, basically, every time they press enter, the message will be written to the server, right? That makes sense. So let's show the client now. Yeah, we just open it, some error checks, client side, and then a little message when when the client has been connected to the server. And then, oh my God, what's happening with all this green? And then I'm reading message from the server. This is a capital F for no reason. Um, yeah, and then we're just reading whatever we're writing in the terminal, right? Sound good? So let me just compile these. And okay, so on one terminal, we have to run the server. So then it's just waiting, right? It's looking for a client. And then we can go to, what's the other one? Um, we can run the client. So it'll wait for a sec. It's looking for it, right? Boom. So it's connected both ways. So now these two, the client and the server, are connected. In the server got a client for reading. The server side is connected both ways, right? So now in the client, we could type hello world. So we typed hello world. These are the characters that we wrote, and we're reading message from the server, and it has received our message. Cool. We can go back to the server now. Hello world. This is optional. But so got it. Perfect. We could close and just end that too. Okay, question 2. The game.c, which is a dice rolling game, uses pipes to coordinate players. Now change this so it uses FIFOs instead of normal pipes. So we can nano assignment game dot c. Okay, so it says the normal messages from the in-class program. This is a two-player game with a referee. Um, we delete the FIFOs if they already exist, and then we create them. This is just a little error check. Then we open them for reading and writing because FIFOs, for them to work, they have to be opened on both ends. Then we fork child processes for the players. So one child will be, player 1, one child will be player 2. Yep. So player 1, this is basically as normal. They roll the dice, they get their value, it reads it, you know. This is actually the dice rolling part. Playing my dice, we roll the dice, it'll get a random number between, what? I think they roll 2 dice. Yeah. They get a total and they're going up to 50. Basically the same as the other one from in class. So we go / assignment game. Okay, it's going pretty fast, but each player is rolling and they're getting certain value from the dice, and it's totaling their values every roll. And okay, so TT plays, he got 8 points, which put him over 50, so therefore he won. Total TD's like, game over, I won. That's it. Finally, we have to, question 3 uses this rule, right? And we have to demonstrate it. So we create a pipe, close its read end, install a signal handler, write to the pipe some information, it could be anything, and then check the return value and then print out its error. So it should just, this is the pipe handler. I didn't do this, but I could have just easily returned -1, whatever. And then pipe problem, broken pipe. That's what it should say. So we can nano sig pipe, sigpipe.c. So here's our handler message, right? Caught the sig pipe signal. So we have our pipe, some error handling, close the read end, right? Read end. And then we install our handler via this. SigPipe handler, that was from up here. So we install it, more error checks, and we write a message to it. So it's going to be trying to write this, but as you can see, it'll have a problem and it'll say broken pipe, right? So we're writing to it, and then this will be the error message, and then it'll exit. We close it at the end. Cool. Sig pipe. Caught the sig pipe signal, so it caught the signal, but it encountered that error, right? So error, broken pipe. That's about it.